So when you think about definite integration, you always have to remember why you were doing what you were doing. When we first started integration, we were finding the area under the curve. When we first started doing definite integration, we were taking a curve like this, and we were finding the area underneath it. Okay, and so when we went all the way back to differentiation, that would be like slope of the tangent and things like that. And so as you progress, you have done differentiation and integration for like every type of problem just about. And so now we're going to start introducing what happens then when you want to find the area between two of them. And it's logical. I mean, you're going to take the area under this guy, which is this one, right? That's the whole area under that curve. And then you're going to take the area under the second curve, and then you're going to subtract the two, and you'll be left with what's left over. Like that's what you're doing, area between two curves. All right, and that's actually the formula. So if you look at the top of page 413, you get this little formula here. If f and g are continuous on AB and g of x is less than or equal to f of x for all x in AB, then the area of the region bounded by the graphs of f and g and the vertical lines x equals a and x equals b is the integration from a to b of f of x minus g of x dx. So a couple things to point out here. One, the higher graph has to go first minus the lower graph, right? So you have to make sure that you know which graph is which. You can test points because it says for all of the points in between those two regions, right? And so you can literally pick a point in between A and B and see which one's higher. Plug it into F, plug it into G, and that'll tell you which one is literally higher on the coordinate plane. That's your Y value. So it won't always give you a picture. In fact, it rarely gives you a picture. So you do have to figure out which one's which. But then you just integrate the first one, subtract, integrate the second one. And you find the area in between them. You will notice they have the A and the B here. So we have A and B. So it is a definite integration here. And you are trying to figure out the area between these two. And they've given it two different ways, showing you A and B here and then showing you just a cap here. It's the same thing. All right. So you do it. Here we go. Example 1. Find the area of the region bounded by the graphs y equals x squared plus 2, y equals negative x equals 0, and x equals 1. All right. So they have given you your boundaries with this x equals 0 and x equals 1. So when I'm setting this guy up, that is my lower and upper bound. So I'm going to do my integration from 0 to 1. All right. Now they have a picture here, but you won't always have a picture, so you really need to figure out which one's which. From 0 to 1, you could do 1/2 if you wanted to. But if I plug in a 1/2 into this guy, I'm going to get some positive number, right? I'm going to get 2 1/4 to be exact. If I plug in 1/2 here, I'm going to get negative 1/2. So this is obviously the guy on top. This is the higher one, and this is the lower one. So even if I didn't have this picture to tell me that, that's how you figure it out. Plug something in your region and figure out which one's higher, and that's your higher one. All right. And we're going to do some where they intersect and where they flip and intersect. But for these, they've given you the boundaries. And so you know that you are going to set it up with this top one first. So we'll have x squared plus 2 first. And we are going to subtract my negative x d of x. So that's what it looks like for us. And you can do it all together. Like does not matter one way or the other. I will say they put it in standard form when they did it, but honestly, so we're just going to take if I had like terms, I would actually go ahead and combine those. But the only thing I'm going to do here is that's minus a negative. So I'm going to integrate this right here because it's subtracting a negative. But other than that, what's the integration of x squared? Well, that's 1/3 x cubed. Integration of 2, that's 2x. an integration of x is 1/2 x squared. And I am doing that from 0 to 1. And they were very nice because all of those zero out. So I really just have to do it for 1. And so I can plug in a 1. I get 1/3 plus 2 plus 1/2. When you get a common denominator, your common denominator is 6. So we get 17/6 as my final answer there. right, so what you'll notice is different about this example is that they don't give you boundaries from left to right. So basically they don't give you your upper and lower bounds, right? They just give you these two graphs. And they're saying the region bounded by these two graphs. What you need to know is these two graphs intersect. And so the boundaries for these two graphs are where they intersect. So what you have to do to begin with is set them equal to each other and figure out where exactly they intersect. So your first step is not to set up your integration because you don't know it. Your first step is to set these guys equal to each other and figure out what your answers will be and what your bottom and top bound will be. So when you have something like this is way back from like Algebra 1, Algebra 2 days, you need to set it equal to 0 and factor and solve. And so move everything to one side. So I'm going to have x squared plus x minus 2 equals 0. Really easy factoring that they gave us, right? X plus 2, x minus 1. So that means x is going to equal negative 2 and positive 1. And so from that, I just got my boundaries of negative 2 and positive 1. All right? You still need to figure out which one's higher and which one's lower. So you can literally plug something in that's in that boundary here as 0. Well, putting a 0 here is going to give me a 2. Putting a 0 here is going to give me a 0. So this guy's higher than that guy. All right? So that's how we're going to set that one up. We're going to say 2 minus x squared minus x. And that's my dx there.
This is the same, you just have to find
Yep, you have to find it. So that's literally all we're doing differently here. And so we're going to take the integration of this. So we're going to say 2x minus 1/3 x cubed minus 1/2 x squared from negative 2 to 1. Plug it in. 2 minus 1/3 minus 1/2 is my 1. Plug in a negative 2, you get negative 4. 8/3 and negative 2. Common denominator here is 6. Common denominator of 6 is going to give me 12, 2, 3. This is going to be 24. 16, and this is 12 over 6. So 12 minus 2, 10, minus 3 is 7. 27 over 6. Yeah, so yeah, that is 9/2. in this particular example, they only are asking us for one of the regions. There are times when they're going to, which is the next one that we're going to do on Monday, where you have things that intersect and then come back and you actually have two regions bounded. And one region's on the top and this one is on the bottom and the other. And this is actually what happens here. You'll see that this graph is on the top right here, but then after they cross, it's now on the bottom. And so that happens, and they'll ask for both regions. In this case, they're just asking for one region, so we're just going to do this one region here. And so we do have to figure out where they intersect. And so we're going to do exactly the same. This is just trig instead of, a regular function. They want sine and cosine. So we're going to say, well, where do the sine and the cosine functions equal each other? All right. Just one of these regions. So we can just go from 0 until the 2 pi. So we can just, or probably we'll do it just from 0 to pi because they only want one. So where do sine and cosine equal each other? That's an interesting question. There's 2 places on the unit circle where they equal each other. Where do they equal each other exactly? Right, and so the other way you can do this is you can divide both sides by cosine, and you could say, where is the tangent equal to 1, right? And that's at pi over 4, square root of 2 over 2 for both of them, and 5 pi over 4, third quadrant, where they're both negative, all right? And so that's going to happen at these 2 places, and so we're going to find the area between these 2 places. Now, in that particular cycle from pi over 4 to 5 pi over 4, you do have to figure out which is on the top of that graph and which is on the bottom of that graph. If you know the sine and cosine graph well, you're going to know that sine is on the top there. But if you don't know it well, you can pick out something like pi over 2. Pi over 2 is in between those. Pi over 2 sine is 1, cosine is 0. And so you can look at it that way if you want to. So we're going to do from pi over 4 to 5 pi over 4, and we're going to say sine of x minus cosine of x dx. So you have to use your antiderivative. What's the antiderivative of sine? Negative cosine. And the antiderivative of cosine then is just sine from pi over 4 to 5 pi over 4. We thankfully know what the sine and cosine is for this one. 5 pi over 4, your cosine's negative square root of 2, but we have a negative in front of it, so we have square root of 2 over 2. My sine is also negative there, so minus a negative, so we're going to say plus square root of 2 over 2. Pi over 4, it is just square root of 2, so we have negative square root of 2 over 2 minus square root of 2 over 2. So we have, if we do this through, right, we have 1, 2, 3, 4 square root of 2's over 2, which gives us 2 square root of 2.